Velkommen til DMN og Ensums webinar. Jeg har i dag haft heldet at få besøg af professor Sfard, som har arbejdet i mange år med matematikdidaktik og er velkendt rundt i hele forskningsverdenen for sit store arbejde. Hun er til daglig professor emerita ved Universitetet i Haifa i Israel, men har også arbejdet i Bergen i Norge. Hun har været ved universitet i USA og i England, så hun er kommet godt omkring. Hun er specielt fokuseret på kommunikation og sprog knyttet til det at lære noget i matematik, og det er det, vi skal høre lidt mere om i dag. Vi vil gøre, som vi plejer. Anna får 25-30 minutter til sin præsentation, og så vil vi efterfølgende have et break, og derfra vil vi komme tilbage, og Anna og jeg vil så have en diskussion af det, hun har fortalt. Så welcome, Anna, to you, to Copenhagen. I'm told of your big work about math didactics, so we are glad to have you here in Copenhagen to hear some words from you.
Thank you, Bent, and I am incredibly happy to be here. Thank you for having me. I am always happy to come to Denmark and to Copenhagen in particular. I have been here many times, but every time it looks like something new. Now, I hope to reciprocate indeed by telling you something that may be new to you, even though you seem to know everything about teaching mathematics. And this is about something that is happening and quite often in the classroom, but people who are there or even observers are not necessarily aware of it. You will say this is trivial. Of course there are things in classroom we are not aware of as teachers, for example. Yes, but will be talking about things which are happening and which are influencing, impacting the success of what we are doing, whether the kids do or do not learn mathematics and how they do it. And if they are so important, it is important for us to be aware of their existence. So this is the theme. And rather than telling you right away what these things are, I will give you an example. So the example comes from the published research done by my ex-PhD student. This is the name of the journal and of the paper in which it appeared. And the story goes like this. So Einat was her name. She was teaching after-school classes of 30-year-old students, especially those who needed a little bit of support in mathematics. Here is the little classroom in which she had these meetings with these students. The focus this time will be on her, the teacher, and one of the students by name Dana. The background of Dana is as follows. She was an art student, as I said, and in school she had considerable difficulties with mathematical problems. Einat's task was to help her. After a brief period of work with Dana, the teacher, Einat, decided that the girl is clueless, perhaps even learning disabled. But then something happened. And Einat kept a journal, and in her journal this one day when this happened, she wrote as follows. I started looking again at all the examples of Dana's cluelessness. And lo and behold, in none of them could I prove that Dana had no idea of what she was talking about. But what was worse, I started seeing how I was missing significant teaching opportunities. In dismissing Dana's suggestions as nonsense or just guesses, I failed to notice that she actually had important ideas every now and then. I just committed one of the oldest teaching sins. I concentrated only on what Dana did not know and completely ignored what she did know. And she continues, by the graver consequences were that Dana learned from me, yet again, that her own thinking was irrelevant and unimportant. Was it then a wonder that she continued to act ritually, hardly ever thinking for herself, No one ever asked her genuinely to justify her claims according to her own set of rules. She was taught over and over again that the only rules that counted in this mathematical game were those established by others. It was then that I realized I was part of Dana's problem, not a part of her salvation. So you can see that suddenly the teacher noticed something that was in her class before, but she was not aware of it. And she completely changed her mind about the child's mathematics. Look at these two sentences. She speaks about Dana's own thinking, and she speaks about her the rules of others which are not like the rules of the girl. So here is a kind of hint that the source of the problem is that these two people, the teacher and Dana, were probably participating in different kinds of communication without even realizing. So another teacher understood that there was a communicational gap between them, that they thought they communicated, but the communication was not going well, and for a reason. There was this communication gap between her and Dana, the student, but she, the teacher, did not realize that Dana was implementing tasks different from those that she, Einat, had in mind. That is, Dana was not doing wrong things about right tasks. She was simply doing correct things in order to implement other tasks. Okay, so we may say, all this is so important to me because mathematics is, for me, mathematics itself is a form of communication. That is, what is going on in the classroom, of course, is a communication between the teacher and the student. But it is not only communication of teaching and learning. Mathematics itself is a form of communication. If you buy into this view, if you buy into the view that mathematics is a discourse, you start understanding how important it is that the two participants meet in the same discourse and not each one of them in his or her own. So this approach to mathematics, the one according to me to which mathematics is a form of communication, I call it, and my colleagues call it, cognitive. It is a combination of two words, communication and cognition, and I combine these words against the better judgment of some English speakers in order to signal that communication and cognition, thinking, especially mathematics, are two things of the same kind. When I do mathematics, I communicate with myself in a certain way, and I tell myself in this discourse mathematical stories. So plan of action for this short meeting is the following. I will say a little bit more about communicational gaps. I will show that sometimes the gaps are inevitable, and in fact they are opportunities for learning. Sometimes they could be avoided. In this case, they are an obstacle to learning, and I will end with just 2 words about how we can live with those inevitable gaps. So let me take you through thought exercise, thought experiment. Look at these people. They are clearly in disagreement. They are saying different things. They are pointing to something behind the bush that both of them can see. We cannot see. They can see. They are pointing to a number. This I do know. There is a number there, and I also know that their job is to implement a certain operation on this number, but they get different results. So my question to you, when you look at it, is what may be the reason for this difference in answers, and what can these guys do to arrive at an agreement? I assume that you have assumptions when I'm asking this question, the assumptions each one of us has as a teacher in a mathematics classroom. First, the task has a single correct solution. This is why they are displeased with the fact that they have 2 different. And when the solutions differ, at least one of them must be wrong, right? Of course, if there's one solution. But now, I want to disclose something. Here is the number, and the operation was to multiply it by 3. So look at it And now think again about your assumptions. The task has a single correct solution. Mm-hmm. Is 18 or 27 wrong here? And when the solutions differ, at least one must be wrong. Is it true? Probably not. Both assumptions must go away. So what we have here is that we have two people with different perspectives. You have two people, if you wish, coming from different discourses, interpreting the signs in different way, the same sign. And here is the situation in which both of them are right, even though they have different solutions. We have a clear case of communicational gap here, which occurs when two people interpret the same thing, words or signs, differently. The gaps are most likely to occur when people who talk to each other are participating in different discourses. So now I need to unpack this word discourse. Previously, I used it as a synonym of a kind of communication. So discourse, I will now say it, is like this game. Here is a game of chess. This game is a communicational game, a game because there are rules according to which all the participants behave. And those who can do it constitute all together, whether they are close to each other or far from each other, a communicational community, a community of this discourse. Those who can't are out of this community, and some people are partly in the community if they can only participate passively because they can't yet do anything on their own. Now, this form, when I say communication, I do not necessarily mean talking. I do not necessarily mean verbal communication. As we all know, communication is multimodal usually. When we speak, I am now gesticulating and I speak. So this is another kind of sign which helps me. We very often think in images or point to images and so on. So it is not only words. Sometimes there are no words and we still communicate. It may be with others or with ourselves. And when it is with ourselves, we call it thinking. Once again, it's a form of communication, self-communication, not only in words. We not always think in words, or in words only, very rarely in words only. So mathematics is an example of a discourse. It is a kind of communication. Two discourses with the same vocabulary may be different because they use words in different ways. We saw an example. We saw also an example of a knot which falls into this category but needs a little bit more unpacking. And there are also other kind of discursive gaps or reasons that two discourses seemingly constituting a single one are in fact different, but it is difficult to see. This kind of difference often occurs between the teacher and their students. That is, people who are in the same conversation talk to each other, very often feel that they understand each other because they are using the same words, but in fact, risking falling in a discursive gap because they are participating in different discourses. Discourses which either use the same words or symbols in different ways or are done according to different rules, which in themselves the rules are invisible. So when we have these discursive gaps, it is dangerous. The situation creates the most dangerous gaps, ones that are likely to be invisible to interlocutors when there is the use of the same words or symbols in different ways, because then you simply cannot believe that somebody is using the words you are using in a different way. This is transparent to us. And in this case, when we are standing on the verge of invisible gap, we are only too likely to fall into it. And therefore, it is of utmost importance to make ourselves aware of those invisible gaps. So I will be talking about minding the gaps in this talk. And my plan, according to my plan, the next thing for me to do is, after I clarified what communicational or discursive gaps are, Did I clarify? Was it clear?
Yes.
Thank you. Is to say a few words about these gaps, the kind of gaps which are inevitable and also should be used as an opportunity for learning, as an opportunity for the teacher to give her hand to the student who is standing on the other side of the gap and bring him or her to her side. So my example is multiplying by fractions. Teacher-student conversation. The teacher says, so what is, to the student, and writes, you can see what she writes. I can read it, but it is important to see it because it's only written for the student. It's not stated. 1/3 times 12. The student has no answer. The teacher says, try again. 1/3 times 12. I think, don't know. Once again, insists the teacher. 1/3 of 12. Oh, it's 4, all of a sudden. The teacher, great. See, when you think about it, you know how to do it. So what happened here? Anything unusual? You will probably say, not necessarily. At least for the teacher. The teacher is accustomed to situations like this. Students do not always immediately give proper answers. They must think. When they think, they know this is what she said. But I want to have another look at this and another take. So let's look at this conversation. First of all, let's look at this first part where the student did not know what to say. And then let's look again on the part in which he suddenly was able to say something. What is the difference between the two? What is the difference? We may become aware of the difference when we take a closer look at what exactly is being said by the teacher about the operation to be performed. So here she says, she shows this, here she says this, and here she says this. 3 times the same task from the point of view of the teacher. The question is whether it was the same task in all 3 cases for the student. The first answer is, of course, why not? It is the same thing in different words. But don't forget it's a young student. He hardly heard about fractions so far. He looks at this, and what he notices is the following. The dot, which symbolizes multiplication, the word times, which once again symbolizes multiplication, and then, okay, and this, of course, these two put him in the discourse of school arithmetics, operation on numbers. But then, okay, this is the words and symbols that evoke numerical discourse, but then look at here. Suddenly, there is the word 1/3 of 12. It is no longer a symbol or a word for any numerical operation. This time, it is something that you do to physical, concrete things. You take 1/3 of a pizza, 1/3 of the cookies which you see on the table. So the discourse in which the student participates when he suddenly can give an answer is the discourse of taking a physical part of a physical whole. And this is a different thing than doing operations on numbers. And you can safely conclude that at this point in time, the student has no idea that the operation of multiplying by fraction is equivalent to the operation of taking a certain part from a physical thing. So we have here numerical discourse, here the discourse on parts of the whole. So we have, while the teacher is participating all the time in the numerical discourse, regardless of what she's saying, the boy is only able to participate in the conversation when he enters the discourse of parts of a whole. So it was the same task for the task setter for the teacher, and different for the child. 1/3 times 12, the discourse was numerical. 1/3 of 12 was parts of whole. The task was different. Here it was calculation, here it was taking a physical part, and the procedures, of course, were different. Okay, so my comments. This gap between the teacher and the child's mathematical discourse was inevitable. So the teacher was not, at this point, probably aware of the gap, because she said, now you know. She thought that he now knows what is 1/3 times 12. He knew a little bit different thing. But I claim that she could not avoid this gap, even if she tried, even if she was aware. Why not? She was unaware of this gap, but the gap was inevitable. Why was it inevitable? Because children are not born with the knowledge that numerical operation of multiplication by fraction is equivalent to the action of taking part, physical part, of a material thing. By no means. They do not know it. So the only thing at this point that the child could do when he was still unaware of what this mathematical operation is all about was to return to what he knew from everyday life, which is taking 1/3 of the pizza. He could do it now. So it was inevitable. There must be a stage in learning when he already knows this because it comes from everyday life, but he doesn't know the other thing. If it is inevitable, we need to be aware of it, and we need to know how to help the child out of it. The gap, if left unattended, would be dangerous. But and it is dangerous as long as teacher is unaware of it. But if she is, she may try to build on this gap. She may use it as, first of all, a diagnostic instrument, and then as an opportunity for learning, as an opportunity to tell the student, you see, this and this, these are the same things, and not only say it, right? But work with him in order for him to see that these two things are equivalent for the sake of this kind of task. So this is the case of inevitable gaps, which constitute, if we are aware of them, an opportunity for learning. What about avoidable gaps, which we should rather avoid indeed, because they constitute an obstacle for learning, not any kind of opportunity. So my example comes from a classroom, this time 11th grade, in a classroom where students on that day were supposed to learn for the first time about, don't be scared, quadratic inequality. The wisdom of teaching about quadratic inequalities may be questioned, but this is what they were learning, and we will follow them. So I will be talking this time about the gap between what the teacher thought he was doing, between the task he thought he was implementing, and the task the students were able to read from what he was doing. He thought he was doing one thing, and there were signs that the teacher thought he was doing a different thing. How is it possible, you wonder? Don't forget that very often that not only teachers interpret what students are doing, what tasks they are implementing, but also students are interpreting what the teacher is doing, and so they learn. So this is how it goes, how it went. The inequality x squared greater than 4 was written on the blackboard, and the teacher pointed to this inequality, and he said, we want to solve for x. And then he said, pointing to the brackets after he decomposed, he did some manipulations and decomposed what was here into this formula, x minus 2 times x plus 2, and he said, we are saying any of these brackets is equal to 0. And then he said also, and then we transpose x something, probably 2 or minus 2, and we get x equal 0. So these are 3 expressions from a conversation, teacher's expressions, which I chose to show you. You don't have to try to understand what he was doing or how to solve this inequality, enough to listen to the words the teacher was saying. Before I analyze and before I tell you why I brought these expressions, I want to talk with you about two types of mathematizing, two types of mathematical discourse, if you wish. Discourses that differ not necessarily in the words that are being used, not in the procedures which are being performed, but rather in what tasks these procedures serve in the eyes of whoever engaged in this kind of mathematics. So there is ritualized mathematizing, doing mathematics in a ritualized way, communicating mathematically in a ritualized way, which is being undertaken for social reasons, like I want my teacher's approval, I want to avoid punishment. As a discourse for others, I would never do it myself. I would never think mathematically for myself. It is only because I'm expected to do so in the classroom. Maybe performed mainly through imitation. I cannot invent it myself. I can only do what other people are doing. And is usually heavily scaffolded by others, because if you don't really understand why you are doing something, somebody usually might help you even in the implementation of the procedure. This is not necessarily the kind of mathematics we want for our students. The type we usually do want will be called explorative mathematizing. How is it different? It is undertaken not for social, also for social reasons. This cannot be denied, but not only for social reasons, predominantly in order to know more about something, whatever mathematics has to offer. It is not only a discourse for others. It is also a discourse for others, but this is also a discourse for ourselves. We can sometimes turn to this discourse when we want to solve our own problem on our own accord. It is performed not mainly through imitation, maybe also imitation, but also by asking our own questions. And when we are really skillful in this discourse, it is unscaffolded by others. We can do it ourselves. So, and how these two types differ from one another? What are the differences between ritualized and explorative? So, first of all, there's a difference between what these discourses are all about. A ritualized is about actions with symbols. I have nothing else to talk about. And explorative is about properties of mathematical objects. But you may say, is there a difference between symbols and mathematical objects in the same thing? If it was the same thing, you would never say things like these two signs, two squares multiplied by each other, and then another formula. We say these two signs, these two formulas, represent the same function. If mathematical objects were signs, you would never say such a thing, that the same function is represented by such different signs. Or we would never say that the signs, you see, 1/2, 4/8, 0.5, represent the same number. So number cannot be any of those signs. It must be something different. Function cannot be any of those expressions. It must be something different. I will not go into the question of what exactly it is, but enough that it is the same number for the different representations and the same function for the different representations. Except for this one difference, there are other differences as well. I will not elaborate on them now, because right now I want to concentrate on the first type of difference, this one. Ritualized is about actions with symbols. We do something to symbols. And the explorative is about properties of mathematical objects, and there's different kind of talk. So let's look again at what the teacher said, and he said, we want to solve for x. We are saying any of these brackets is equal to 0, and the last one. And I claim that in all these cases, the statements were on people's actions with symbols. Okay? So actions, yes, it was our actions. We solve, we are saying, we transpose our actions. With what? I said with symbols. Yes, with x, with brackets, and here with a numeral, which was being transferred physically from one side to another while changing the sign miraculously. You may wonder, so what? So the teacher was using the discourse which, according to my first criterion of ritualization, was ritual. I don't suspect the teacher that he himself did not practice explorative mathematizing. And he was teaching this way, he probably thought that he was teaching explorative mathematics. But he was oblivious to the fact that the way he was talking concealed this fact for the students. So how could he have said these things differently? For example, he said, we want to solve for x. He could say, what are the numbers x, the square of which is greater than 4? Or he could say, another way of saying this, for what numbers x is the value of function x square greater than 4? He was saying, are we saying any of these brackets is equal to 0? He could have said, what must be one of the numbers the product of which is 0? And then we transpose them. He could have said, we subtracted 2 from both sides of equation instead of transpose them. Or he could said, two functions remain equal if we subtract the same number from both of them. So what we have here is discourse on our actions with symbols. Here, discourse on the properties of numbers. Here, discourse on the properties of functions. So the first of these discourses is clearly ritualized, the other explorative. So what happened here is that a well-meaning teacher who was himself doing mathematics exploratively and believed that this is what he was doing to his students was in fact showing them, by the way he was talking, ritualized mathematics. Now, I was not trying to say that abbreviated expressions are forbidden, that we cannot use those expressions he did. We may, but most certainly it should not be the only way we talk, because if it is the only way we talk, we leave very little space for explorative discourse. So we should think about how students interpret us, not only about how we should interpret our students. This is one more lesson from what I wanted to say. And in all these cases, we are talking about communicational gaps, which are present in classrooms, but are usually invisible for either students or teachers. So now I'm going to the last part of my talk, very short this time because I have no more time left. And how can we live with communicational gaps? We cannot avoid all of them, so how can we live with them? See, this kind of gap cannot be avoided. We need to learn to live with it, and I can only throw some principles, some slogans, and how to implement these slogans I will leave to my audience today. We need to try to turn the inevitable gaps into opportunities for learning, because they are inevitable when they are a result from unavoidable stage in learning. Harmful gaps, we have seen one example, should be prevented, should be avoided. And again, we need to know that there is a gap. Some seemingly conflicting visions should not be seen as mutually exclusive. You could see these two folks who are doing mathematical operation on the same symbol, getting different results, but both of them were admissible. In all the cases, our first task is to learn how to make gaps visible. And my research is devoted in a big part to identify those kinds of gaps which are most probable and most often seen in classrooms. Thank you.
We will be back in a few minutes, and Anna and I will have a discussion about the slides. Vi ses. Velkommen tilbage fra pausen. Anna og jeg vil nu have en diskussion af nogle af de punkter, som hun har vist jer. Jeg kan høre et anbefaling, jeg siger det, der er flere gode bøger af Anna, hvis nogen af jer vil trænge dybere ned i det her. Men let's start, Anna, and my first question to you is, I think many teachers in Denmark discuss what kind of teaching they want to do, and a lot of teachers in the talk about going from imitation, who is very often seen around, to more problem-solving, exploring work for the child. And for me, I see you talk about a balance and not leaving the imitation. Could you
elaborate?
Elaborate, yes.
Yeah, we all have this tendency, the moment we recognize something as good, we also recognize anything that is not this thing as bad. And it is a bad thing, a bad habit, because nothing is white and black. And when it comes to imitation, maybe the word imitation does not sound too inviting. Maybe the fact that I used imitation, if you remember, as a part of my description of what ritual is all about, ritualized mathematics, and then I also claimed that we wish our children to leave the school not with ritualized, but with explorative mathematics. So all this points to the fact that imitation is maybe not such a good thing. On the other hand, imagine a really little child who learns language without imitating. Imagine an older child who learns about fractions without first imitating what the teacher is doing. Does the child have anything else by those procedures that the teacher performs that is related to fractions in the beginning? Very little. The sign 1/2, 3/4, it cannot yet say much to him, even if it is somehow related to what the children say in everyday life. True, when children start dealing with fractions, they usually already are able to use in everyday speech words like half, like third, maybe even 3/4 in different contexts. But it's a long way from here to the moment that 1/3 or half or 3/4 become an object for them, a mathematical object in its own rights with its own properties. The connection between these two situations happens when we take the child by hand, encourage the imitation in the beginning, because the child needs to have something to reflect on, to ask herself, why I am doing this, not why I am doing this. Why is my teacher doing this? It must have sense. It is somehow related to situations I know. Let me find out what it is all about. But in order to be able to say it, in order to be able to say, let me understand what it is all about, she must have it. And the it is the way of doing things with those symbols. So this is the first thing she can learn. Then she can reflect on it. After she imitated, because there was no other way to learn it, she can reflect on it, and slowly but surely she can reconstruct to herself the reasons why you, the grown-up person, think that all these manipulations with all these strange signs are so very much useful in life. At certain point, after it started with imitation and continued with intense reflection on what it is all about, reflection in which you as a teacher help children connect these things to something she knows from other parts of her life. In the end, 1/2 will become a number, 1/3 will become a number, and numbers have also operations that can be performed on them and have life of their own. So what I'm trying to say is that you cannot avoid imitation. If you try to avoid imitation at any stage of learning, you are doomed to probably not being able to really teach mathematics, because it is absolutely necessary. But it is absolutely unjust to give imitation such a bad name if imitation for you means not just mechanical repeating, but a repeating constantly accompanied by the question, why I am doing this? What is it good for? The question to which the child must find the answer of herself. You can help her as a teacher, but it is the child's task to imitate and to think. I call it reflective imitation. Okay. Reflective imitation is a very important part of learning, and I want to say more. I use just one example, that of fractions. The truth is that when we learn mathematics, there are many special transitions. Along the curriculum, there are many points in which something which I call critical transition happens. What is critical transition? When in order to learn a new thing in mathematics according to the curriculum, let's say you already know what integers are, you now need to know what are rational numbers. It is not necessarily the order, but let's assume that this is how it is. So in order to make this transition from the world which only contains integers, a positive, negative, but only integers, to the world which also contains numbers which are not integers, in order to make this transition, you must, without realizing usually, make a certain change in your existing mathematical discourse. Some things must be given up. Some things that were considered as true for every number so far will not be true for every number from now on. In the case of transition, for example, from natural numbers to integers, they claim that if A is greater than B, then 1 over A is smaller than 1 over B will no longer be generally true when you add negative numbers. So things more important than that even need to change. Some rules must to change when you make transition from one kind of numbers to a new kind of numbers at every stage. And not only here, also in geometry, there are these kinds of transitions. Why this dramatical transition? Why something changes? Because you add usually new mathematical objects which did not exist for the child before. Now, when for the first time you as a teacher speak with the kids about these new mathematical objects, how can the child understand or think she understands what you are talking about? She cannot touch it. She cannot feel it. She cannot smell it. She can only maybe talk about it and listen to you talking about it. And she has somehow to arrive at these objects by what? Only by trying to participate with you in this conversation of these objects, because otherwise, how come? On the way, she will also understand maybe what these new objects are good for. So when these new objects appear, the student has nothing she could use in order to, in this sense, mathematical objects are dramatically different from everyday objects. You can tell a child about giraffe. Never in her life she saw giraffe, but she knows what animal is. You can show her a picture. You can talk to her about a moon, the moon as something that goes around the earth. The child, soon after she is born, is aware of the existence of the moon. She doesn't know much about the moon. She has all kinds of strange ideas about it, but she knows it exists. You come and tell children, let's talk about -2. What is it? Where it came from? Nothing. So, what I wanted to say is that at this point, when these critical transitions occur, in order to make it safely, there's no choice. The child can create for themselves these objects only by talking about them. For this, she needs to learn your procedures. In the beginning, then can only be imitations. So ritualized mathematics is a necessary beginning then, and only then we will transform it slowly but surely into explorative.
I have thought about it because I know certain children, when they hear teacher talking a foreign language and don't know about it, they get a resistance for the math. Wouldn't it be necessary to have a knowledge in your mind for the child and the confidence to the teacher that the child know there will be an explanation where I can relate it for something in my daily life?
Yes, I think it is very important. In my work, I speak about something which I call learning-teaching agreement, unspoken, unwritten, which is a condition for putting up by the child and by the teacher with the fact that at certain stages of learning, acting ritually is indispensable. Because we have little patience today to rituals, right? We want to do everything when we know why we are doing this, what we are doing, and so on. We want to explore, we want to find new truths about the world on our own. So ritual does not sound right. In order for the child to do this ritual and to be patient and to do things, as you say, even though she does not yet know what it is good for, maybe even without asking you what it is good for, as children often do. Why do we have to learn this, right? But rather taking it as a challenge for herself. I must understand what it is all about, why I am doing this. In order for this, I have figured out why my teacher is doing this, why generations of people were doing this. There must be something good about it. So this confidence that what you are offering is worth being imitated, because in the end it will have some kind of use, is very important. So this learning-teaching agreement for me has three parts. The first one of which is the agreement about the fact that there is somebody who is the leader in the discourse. I may have my discourse, you may have yours, but we all agree that your discourse is the one to aim for, and I can be confident that it will be useful also to me the moment I can participate in it properly.
Okay, another question. Also around when I discuss with teachers, we talk about how to look for the children's understanding. It's very important for many teachers. It's okay, they can have some procedure, but do they understand what they are doing? And for me, in your research, I see a very big connection between the language and the understanding. Could you elaborate some words about it?
So first of all, and I know that you think similarly because we've been talking, I am very wary of the word understanding. I know that I myself use this word several times so far, but when I am to use this word for the purpose of diagnosing what the kid can or cannot do and so on, I am aware of it, and I will tell you why. This is not the only word which we all use, but it's very problematic, because understanding, in fact, is two things. First of all, we are using, even before two things, we are using it in two different ways. We can say, she does understand, she doesn't understand. Binary thing, right? Either somebody understands or doesn't, or maybe almost understands. Sometimes we say, no, everybody understands in some way. The question is how. So how do you understand this? These are two different uses. Okay. But except for this, there are two ideas of understanding. One is your experience. You say, I understand. Your first person understanding is something which you know from inside because there's a certain kind of experience. It's a nice experience. It is this experience which gives you confidence that you can continue and go on. But when I am your teacher and I want to diagnose your understanding, I am using the third person perspective. So what am I talking about? Am I talking about your inner experience? How can I know? Of course, I can learn to know from your behavior. You look to me confident or not, relaxed or not. But this is not the way we are going about it. You are looking at what you are doing, and we decide from this. Okay, he does everything fine. It seems he understands. Now, is the first person and the third person the same thing? Very, very often not. And I had lots of experiences with my own students in mathematics when I was claiming, you don't yet understand, and the student was saying, I do understand, I just couldn't explain myself. And even more surprisingly, I had an experience with a student whom I prized for the fact that he understood something very difficult, to which he said, no, I didn't. I did everything like a machine, but I don't know what I was doing.
That's right.
So these two perspectives are always in conflict, and what, in fact, are we looking for? So I, as a teacher and as a researcher, stopped using the word understanding for my own purposes. I do not try as a teacher and researcher to diagnose students' understanding. I do listen to what they say themselves about their understanding. This is important. When they say, I don't understand, it means this is an outcry for help. When a teacher says, this student understands, I understand that the teacher is pleased with the student. But when I am to decide how to talk about what the student does, I do not speak about understanding. I speak about, is his mathematics explorative enough? Okay. And for me, explorativity is the stage in which I am reasonably pleased with the state of this child's participation in mathematical discourse. Because when you act exploratively, you act agentively, you are on your own, you sometimes use this discourse for yourself. This is, for me, the replacement, good replacement for the word understanding.
But I think teachers often need some kind of observation to communicate how good children behave in math, and they often use if you understand or not understand. Isn't there a possibility to listen to the language the child is using as a kind of scale for how much knowledge they have about it? Okay.
No doubt. So, yes, the teacher needs to know where they are in implementing what they see as their task. And their task is to turn all these little creatures or bigger creatures into skillful participants of mathematical discourse, to make them be able and willing to communicate mathematically. This is their task. And in order to proceed with their work, they have to evaluate on the go, formative evaluation all the time. Did we make any progress? But who said that speaking about understanding is the only way? I do really speak about how explorative the discourse is of the child. The discourse is the child's discourse is how explorative it is, and I have a long row of criteria for deciding whether he or she communicates in explorative way. One of the things is the formulations the child uses. If the child speaks all the time the way that this teacher whom I quoted spoke, that is in terms of symbols and his own actions with symbols, I can say to myself, something is missing. So this is why, but it's only one out of many criteria. And there are others as well.
Sometimes we discuss if a child or a young guy is very good in handling a situation without language, but can do it in perfection, he will find he have understood it. But maybe not. You
not
could
always.
be a very good carpenter and make things in beautiful ways, but not understand why it.
We shouldn't be saying that kids are understood and attained what we wanted them to attain only by saying that they do properly whatever they are doing, properly in our eyes. When we observe only what they are doing, we not necessarily know what tasks they had in mind they were doing. We only know that they perform proper procedures that we taught them. If the school was the way we would like it to be, it would be impossible to judge students as accomplished only on the basis of the fact that the routine kinds of tasks are being performed perfectly by this student. It's not enough. And many students who arrive at highest level, maybe not highest, but high level of mathematics in their final examinations, leave the school and say, no, I didn't really understand what was going on.
I have to stop you now because there's very little time left.
Okay.
Sorry,
okay.
Sorry, but I have two questions more I have to ask you. And one of it, you mentioned in your slides, be aware of the gap, but you didn't mention how.
Okay, I didn't. Because it is tricky. It's difficult. I said I have no time, but in fact,
now you have.
It's tricky. No. So what I want to, first of all, I want to say how you cannot identify the gaps, and then I will tell you how we can. We cannot identify usually the gaps on the run. You stand in the class in front of 30 children. You cannot reflect on conversation that is going on. You can only be in the conversation. It's very, very difficult to identify any gap on the run. We usually act on the basis of a number of assumptions, some of which were in my slides, like assumption that there is one correct answer, and if there is a wrong answer, the answer we consider as wrong, then there was a problem with the procedure, and so we go. We do not reflect, you just have to do. You have to keep the conversation. So this is not the way, and this is why, even though the communication in classrooms goes on for thousands of years already, teachers are still unaware of the gaps. Here is when the researchers come into the picture, because the researchers, especially today, use video recordings and everything that is needed in order to keep the moment and not let it go, can allow themselves the luxury of listening to what is being said, first of all, verbally, without missing a word, without missing a pause in speech, without missing anything that may be relevant to interpreting what was going on, and looking at it as many times as they want and for as long as they want. My many discoveries of discursive gaps in the classroom came from studying time and again 1 minute of recording, 30 seconds of recording. Whenever I was surprised by something, I took the recording of it and I was studying it, looking around before and after, looking into anything contextual that could give me a hint until I arrived at the conclusion, yes, here was the discursive gap, and here is how it worked. Not all discursive gaps can be collected in this way. Millions of researchers are sitting with millions of recordings, studying. They will not cover all the possible discursive gaps, but they can create a decent catalog of most typical discursive gaps and most typical places in the curriculum, like those critical transitions, where the gaps occur, the way in which they demonstrate themselves, and of course, as a consequence, they can also come up with ideas about how the teacher can help the student to make it through this gap, safely from ritual to exploration.
I think also this is a very good issue for the teams at the school. I know a lot of math coaches are listening to us just now and looking for what in the television. And I think if you have situation from the classroom and have a discussion together, it could develop and maybe it may got it possible to find the typical gaps and have it in your mind when you are in the classroom.
It's even better that teachers do that themselves. I said researcher is because I said only researcher has the luxury to look at these recordings as many times as she wants to. because teacher is too busy. So the teacher can do it sometimes, but if the aim is to create a catalog so that everybody can use it, help of the researcher who has this luxury of looking as many times as she wants to help.
Anna, we have got more time. We will have stayed on for hours. I know. Yeah. Thank you very much.
Thank you.
Til jer. Tak fordi I lyttede og så med. Vi vender tilbage en anden gang. Tak for en gang.